Hello everyone, this is the integration of climate change and food chains by Ben Parent and Connor Crozier. So the goal of this presentation is to explain how climate change and food chains integrate, and we will be doing this through objectives. So first we will be describing the topics on their own and giving an explanation and definition, and then we will be going through specific links and forms of integration between these topics. So as we mentioned before, our first objective is to describe each topic. So our first topic here is climate change. So I think we should all be familiar with the topic of climate change. It's very relevant in our news today. So climate change is the change in climate due to increase or decrease of atmospheric abundance of greenhouse gases and aerosols. Some examples of these are carbon dioxide, methane, and nitrous oxide. So the warming of the climate has become very evident to us over the past decades with continually warming air and ocean temperatures. And the main reason behind this is the CO2 emissions from us as humans. So CO2 is the most important driver for warming of the Earth's climate over the past decades. And we have a nice graph there down on the bottom right. It is a graph of CO2 in the atmosphere. It spans from the year 1750 to 2020, and as you can see, there is a concerningly steep increase in the recent years. The second topic of our presentation is food chains. Food chains are the pathway through which material and energy flow in ecosystems. They are composed of trophic levels. We should all be familiar with this concept because we went over it in class, and we have a diagram from class in the top right from ecosystem ecology and ecological energetics. It shows the different levels and how 10% of the energy is brought up through each trophic level. And the first trophic level are the autotrophs, the primary producers. The second trophic level are the heterotrophs, primary consumers. The third, carnivores and omnivores that eat herbivores, which are secondary consumers. The fourth, carnivores and omnivores that eat secondary consumers, making them tertiary consumers. And then finally, we have the apex predators who have no natural predators, and they sit atop the food chain. So a disturbance to one trophic level can impact other trophic levels throughout the chain due to overconsumption or underconsumption. And we can all imagine how this occurs. So if a predator is over consuming a prey, then those prey will not be consuming their lower trophic level and so on.
Now we are going to integrate on the two topics discussed prior, beginning with the effects of climate change on aquatic versus terrestrial food chains. In both terrestrial and aquatic environments, the warming of the climate causes stress upon the food chains. There are studies that show that larger species in aquatic ecosystems suffer more due to climate change than in terrestrial ecosystems. This is caused by an increase in metabolism from warm water temperatures. A warming climate tends to cause an advantage for smaller species in both the aquatic and terrestrial food chains, but is more drastic in the aquatic ecosystems. To the left, we have a picture of the Great Barrier Reef, and it really shows how the aquatic and terrestrial ecosystems can coexist with each other. The next topic we're going to discuss is the effects of climate change on the trophic levels. So typically, a warming climate negatively impacts consumers in a food chain. These are the trophic levels 2 through 5, while the producers, which make up the first trophic level, can be positively or negatively impacted. The reason why the consumers are negatively impacted is because the metabolism of the consumers exceeds their ingestion rates when the climate is too warm. Also, the larger size consumers are more heavily impacted than the smaller size consumers. This is because the larger organisms consume and preserve energy less efficiently. Like stated previously, the producers can be either positively or negatively impacted by a warming climate. The release from the competition and/or predators, which is due to the warmer climate, eliminating these two factors can have a positive impact, while the dehydration evidently caused due to the warmer temperatures is a possible negative impact for the producers at trophic level 1. Finally, we're going to give a couple examples of the anticipated future effects of climate change on the food chains. First off, climate change is predicted to increase in severity if there are no measures taken to decrease the emissions. Also, further warming of the climate is predicted to cause more extreme conditions such as extreme drought, heat waves, frost, precipitation, and etc. Increased temperature is expected to cause severe disturbances in both the terrestrial and aquatic food chains, specifically the larger size consumers in the higher trophic levels. Large at-risk species are expected to experience the most detrimental impacts, such as shown on the left here, the polar bear, where it's looking to get to land, but it can't because it's stuck on the ledge of ice. So this was our brief explanation on how our two seemingly interdependent topics are more intertwined than one might think. Also, here are our sources from the information that we took, and thank you all for listening.